In this video, we're going to work together to review S8P5, parts A, B, and C, and that's all about the different forces that are around us in terms of magnetic, gravitational, and electric fields. So let's take a moment and review those forces. You're going to need something to write with, a good many highlighters, and maybe even your periodic table to refer back to. So the first one is a magnetic field, and that is a region or area. A region is just a fancy word for area around a magnet with magnetic force. So the bigger the magnet, the bigger the magnetic field will be. A gravitational field is a region around an object that exerts gravitational pull. An electrical field is a region in which an electric force is exerted. And so all three of these fields are regions, and those regions are only as big as the electrical field or the gravitational field or the magnetic field are. It's basically as big as that reach can be. Then we have air resistance, and that's the force pushing up on an object when falling. And of course, we know that things like feathers and parachutes and big pieces of paper like this have air resistance when falling. Leaves, when they fall out of a tree, have air resistance. And last, inertia, we know is also what Newton's first law can be referred to. Objects at rest, their inertia is to stay at rest, and objects in motion, their inertia is to stay in motion. So that is the inertia of those objects. Feel free to pause the video at any time. All right, so what are the three types of metals that are magnetic? We have iron, we have cobalt, and we have nickel. And I had a student a while back that called them Fifi, Coco, and Nini, and that's how he remembered them. And I'll forever remember him for that. All right, so some facts about magnets. Magnets have two poles. The names of the two poles, of course, are north and south. In magnets, opposite poles attract and same poles repel. The closer two magnets are to each other, the stronger the magnets repel or attract. So distance does play a factor in that. So here are some facts about gravity. Two factors that affect the gravitational pull between objects are mass, and then the other factor is distance. Okay, so I want to back up real quick and highlight this and that. If mass increases, if the object gets bigger, then gravity gets bigger. If distance decreases, then gravity increases. That means the objects get closer together. Two factors that keep Earth orbiting the Sun and the Moon orbiting the Earth, the two factors are gravity, that's what keeps us pulled in and attracted, and inertia, that's what keeps us moving. Remember, inertia is the tendency of an object to resist a change in motion. If it's moving, it wants to keep moving. If it's at rest, it wants to stay at rest. So why does a feather fall to earth slower than a rock? If we look back up here, it's because the feather has air resistance. The force pushing up on it, the air pushing up on it, causes the gravitational pull to be not as much. So facts about electricity. All electricity flows from negative to positive. I want us to note right here, do you remember that electricity is the flow of electrons, E negatives? Okay, so add that please. Just like magnetism, opposites attract. A positive charge is attracted to a negative charge, just like a north pole is attracted to a south pole. And a positive charge repels another positive charge. Okay, so we are done with the first page. Take a moment, make sure that you've got it complete, and then flip over to the next page. We're going to keep talking about electricity. All right, so on our next page, we have a picture of this object, and it is an electroscope. So we look right here at this object, and we have a negative rod, so the positives are attracted to it, and that means that these negative electrons are repelling here. So this is an electroscope, and this instrument is used to see if an object has a charge, whether it's positive or negative. It just shows if something's charged or not. What will the leaves do as a result of the rod coming close? The leaves are going to spread. They're going to repel because they're negatives and they don't like being by each other. And why? Why are they going to repel? Because like charges repel. That's why. All right, next we're going to draw a sketch of the fields below. We're going to draw a sketch of a magnetic field, a gravitational field, and an electrical field. And while they are very similar, there are some things that make each of them different. So for our magnetic field, we need to have a north and south pole. And we want to show that with our north and south pole, here's the north and here's the south. That's what to look for with magnetic fields. We want to show that they are stronger at the poles and weaker in the middle. With our gravitational field, to have a gravitational field, you need to have a lot of mass to begin with. And then a gravitational field only has lines of attraction. Gravity only attracts. It does not repel. So only attraction. Then with our electrical field, we're going to have a positive charge. Here's our positive charge over here. And we're going to have our negative charge over here. And they are attracted to one another, so we're going to show our lines of attraction there between those positive and negative charges. So what is proof that a magnetic field exists? Well, there's tons of things that we could write down. One that I chose to write is that magnets attract objects without even touching them. That's called a non-contact force. Another thing is that compasses use the magnetic North Pole. They work off of that without even touching the North Pole. And when we learned about this originally in class, everybody got to hold a compass and see how it worked. What is proof that a gravitational field exists? When you jump up, you come back down to earth. If you drop your pencil off your desk, it's going to fall to the floor of the classroom. And what is proof that an electrical field exists? Have you ever been shocked before? Have you ever had static electricity? Hair sticks up with a balloon. Remember that example from class? The leaves of the electroscope repel each other. So all of those are examples of different fields that exist around us. So that's going to finish us up with S8P5A, and we're going to move into S8P5B. So take a moment and highlight that on your paper. For S8P5B, we're going to define these terms. Our first one is conductors. That's a material that electricity passes through easily. Okay, any type of metal is an excellent conductor of electricity. An insulator is a material that cannot pass, that electricity cannot pass through easily. Glass, plastic, rubber, those are good insulators. Think about things that cords are coated in so we don't get shocked. Conduction, transfer of charges when two objects touch. This is talking about conduction of electricity, and we have just finished reviewing conduction of heat. Very similar in concept. Induction is transfer of charges when two objects do not touch, but they get very close, and those charges are transferred. And last, friction. Friction is the transfer of charges by rubbing materials together. Think about rubbing a balloon on a sweater. Just the generic idea of friction with heat would be rubbing your hands together. So what are 3 examples of conductors? You could pick any metal right here. I chose gold, salt water, ocean water. Humans, we're great conductors of electricity. Our entire nervous system runs off of electrical impulses. Your heart beats off of electrical impulses. That's why if someone's heart stops beating, they shock them with the defibrillator to get their heart back pumping again. What are some examples of insulators? As we said before, rubber, glass, plastic. Diamond, while expensive, is a good insulator. And then to finish us off, our last page, we're going to match these. So what would be friction is going to be C, transfer of charges by rubbing 2 different materials together. Induction, I'm looking for something to get close but not actually touch, so that's going to be here. Without direct contact is going to be induction. And then conduction, I'm looking for something actually transferring charges by touching, and that's going to be A. Okay? So what is an example of friction? Rubbing a balloon on a sweater would be a great example of friction. What is an example of conduction? Touching an electric fence. Ouch. Have any of you actually done that? I have, and it is not a pleasant experience. Okay. What is an example of induction? Feeling a shock because you were where lightning struck. I have not had that experience, but my brother has, and he was definitely shocked, but fine afterwards. All right, so we have made it to section C, and we have just a few more terms to define. These are all 3 devices that we use. An electromagnet is a temporary magnet made from electricity. Temporary means it can be turned on and off. A generator is a machine that converts mechanical to electrical energy. A motor is the opposite. It's a machine that converts electrical energy to mechanical energy. Okay, so looking right here, we have an electromagnet, and we're going to label the parts of the electromagnet. So we have right here, this is a battery. We have the electrons flowing from the negative terminal coming back to the positive terminal. So we want to label our electrons and their energy flow. We have our coils of wire, and we are assuming that this is a magnetic core. And remember, that could be iron, cobalt, or nickel. What is one thing the tool is used for? It's a temporary magnet to move cars. It's also used with hotel key cards to open hotel doors. And how can I increase the strength of the tool? I can increase the number of coils of wire, I can increase the size of the battery, and I could increase the size of this iron core or the nail. So some facts about motors. Motors change electrical energy to mechanical energy. Motors use electricity, and a motor is opposite of a generator. Here are some facts about generators. They change mechanical energy into electrical. They can be made by moving a wire across a magnet, and the faster a generator is turned, the more current is produced. And what are some uses for generators? There's lots of uses. Hospitals especially use them if power goes out. Grocery stores use them if power goes out. People use them for tailgating in parking lots before the big game. People use them for camping. Fairs use them to run fair equipment. So that's going to finish us up with